This lesson is on the product rule and the quotient rule. So first, let's just think about why the product rule is going to work here. So you have an example like this, f of x equals a product, x cubed times x to the fourth. We know that this is really f of x equals x to the seventh, okay, because you add the exponents. And if we use the basic derivative rules that we learned, the derivative of f of x is 1 times 7, which is 7x to the, and then you subtract 1 from that, 7x to the 6th. Okay. The product rule is a derivative rule that says that we multiply the first function times the derivative of the second function plus the second function times the derivative of the first. So written in function notation, it looks like this. If you have a product, the derivative of that product is equal to just writing down the first function or expression times the derivative of the second expression plus the second expression, just write it down, times the derivative of the first expression. Now in our class, I like to think of it as the first times the derivative of the second plus the second times the derivative of the first. And then I even write it even a shorter notation, the first times the derivative of the second plus the second times the derivative of the first. Okay, so let's do that with the product here. Okay, so according to the product rule, which is the first times the derivative of the second plus the second times the derivative of the first, the derivative would be the first, so you copy that down, times the derivative of the second, which would be 4x cubed, plus the second, which would be x to the fourth, times the derivative of the first, which would be 3x squared. Now in our class, I want you to leave it this way, unsimplified, but for the purposes of this illustration, I'm going to simplify that so we can see that it really does work. The product rule does work. So x cubed times x cubed is x to the sixth, and 1 times 4 is 4. So this would be 4x to the sixth, and this would be x to the 4th times x to the second is also x to the 6th, and 1 times 3, that would be 3x to the 6th. And then they're like terms, and they add up to be 7x to the 6th. So we can see that the product rule does work. All right. So we're going to leave it unsimplified. All right, so here's our first real example. Okay, so we have a product. It's a times in there. And so to take this derivative, you could multiply it out, you could FOIL it out, but it's now that we have the product rule, it's a lot easier to use this product rule here, the first times the derivative of the second plus the second times the derivative of the first. And so the derivative of f of x will be the first, which is 3x squared plus 6, times the derivative of the second. So the second's derivative, the derivative of 2x is just 2, and the derivative of negative 1/4, a constant, is 0. So the derivative of 2x minus 1/4 is just 2, plus the second, copy that down, 2x minus 1/4, times the derivative of the first. So the derivative of 3x squared is 3 times 2, 6, x to the 1. And the derivative of 6 is nothing, 0. And that's it. And you don't have to multiply it out. In fact, I would like for you to leave it unsimplified, because then it's easy for me to check your work. And you're less likely to, the more algebra you do, the more chance for mistakes. So in Math 263, we get to leave it unsimplified. You can multiply it out if you'd like. Something easy like this you might want to when you're going to type it in to Excel. But I like it when you leave it unsimplified. I can check it very quickly. And so can you. All right, so that's that answer. All right, let's look at another example. So this one says f of x equals 4x squared times. Now, even though you don't have parentheses, that's still a product. So the first thing that you want to understand is that this is the first term right here. So we might as well put parentheses around it if that helps you. So this is the first and this is the second. And so the derivative is the first times the derivative of the second plus the second times the derivative of the first. We'll use the product rule. So the first, that would be 4x squared times the derivative of the second. There's an understood 1 there, so that just is 1. That's the derivative. Plus the second, x plus 5, times the derivative of the first. The derivative of 4x squared is 8x. And you're done. Okay, now we're going to get a little bit more involved here because we have some rational expressions here. And so before I take the derivative, I really think it's a good idea to rewrite those so that they're in ax to the n form, so we can use the power rule, the basic derivative rule. So I'm not going to take the derivative yet. I'm going to rewrite. So I'm going to rewrite this as x to the negative 1 plus, and I'll rewrite that as x to the negative 2. And then these are already in a really good form, so I'm just going to copy that over. That's not me taking the derivative, that's me rewriting. All right, now I can take the derivative using the product rule. The product rule is the first times the derivative of the second plus the second times the derivative of the first. So the derivative is the first, which is x to the negative 1 plus x to the negative 2, times the derivative of the second, which is 9x squared, plus the second, which is 3x cubed plus 27, times the derivative of the first. Okay, so the first, x to the negative 1, that's negative 1x to the negative 2. And x to the negative 2 is negative 2x to the negative 3. And that's it. And you definitely wouldn't want to try to simplify that. Okay, so that's the product rule. Now, let's look at the quotient rule. The quotient rule says to find the derivative of two functions that are divided, you follow this rule. Okay, the function on the bottom times the derivative of the function on the top minus the function on the top times the derivative of the function on the bottom, all over the bottom squared. So if you write it in function notation, if you have an expression divided by another expression and you want to take that derivative, you write down the bottom one, g of x, times the derivative of the top one, minus the top one, times the derivative of the bottom one, over the bottom one squared. So with letters is what I like to use. I like to say bottom times the derivative of the top, minus the top times the derivative of the bottom, over the bottom squared. Okay, so you got to memorize that. And before we move away from the product rule altogether, I want to say something. So the product rule is first times the derivative of the second plus the second times the derivative of the first. Because you have addition in the product rule, you could, and some of you have memorized it this way, you could do it second times the derivative of the first plus the first times the derivative of the second, and that answer is not going to matter. Okay, that's okay. But notice that in the quotient rule you have a minus here. And a subtraction is not commutative. So it's very important that you don't get this backwards. You have to start with the bottom. Okay, and some teachers in high school teach it like, I think it's ho d high minus high d ho over, what is it, ho squared. But just remember to start with the bottom, because if you start with the top, you're going to get a negative error because subtraction is not commutative. All right, so let's try one. So here is a function with an expression divided by another expression. And so this is your top and that is your bottom. All right, so the quotient rule is bottom times derivative of the top minus top times the derivative over the bottom over the bottom squared. So here we go. The derivative of f of x is the bottom, which is x to the 5th plus 2x, times derivative of the top, which is 4x, minus the top, which is 2x squared minus 3, times the derivative of the bottom, which is 5x to the 4th plus 2, all over the whole thing, the bottom quantity squared. And that's going to be, you want to leave that unsimplified, and that's going to be tricky when you type that into Excel, because this is a nice horizontal division and it's a grouping symbol. So when we look at it, we know we're supposed to subtract first, but when you type it into Excel, you're going to need an extra set of brackets around your numerator to make sure that Excel subtracts first and then divides. You won't need extra parentheses here because there's already parentheses from the squaring. So just be thinking about what's going to happen as we'll be typing that into Excel. All right, let's look at another example. Okay, so g of t equals t squared plus 2t plus 1. That's our top. And we're dividing by 5t minus 1. So it's a quotient, and the quotient rule is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So nothing to rewrite, so we'll just go right into it. The derivative of the function g is bottom, 5t minus 3, times the derivative of the top, which would be 2t plus 2, minus the top, which is t squared plus 2t plus 1, times the derivative of the bottom, which is 5, all over the bottom, 5t minus 3, quantity squared. And that's it. Don't try to simplify. All right. Now, this one is a quotient, but there is a constant, a number without a variable in the numerator. So you could use the quotient rule, but you could also use the product rule with a little bit of rewriting. If you use the quotient rule, you're going to have to do an extra step of simplifying, but it's not hard, but it is required. So let me go ahead and show you what I'm talking about. So if you go right into the quotient rule, bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Notice how I'm writing that over and over. That's what I do to memorize things. Okay, so the derivative of the function g, that's your top, that's your bottom. So that would be bottom, write that down, times the derivative of the top. So anytime it's a constant, not just 1, if it's a 2 or 3, anything without a variable, the derivative of a constant is 0. Minus the top times the derivative of the bottom all over the bottom squared. Okay, so remember I said you have an extra bit of simplifying. We don't allow this. You have to understand, and you of course know, that 0 times that is 0. So you would have to write your final answer without that expression, and this is just going to be negative 10x over 5x squared minus 3 quantity squared. All right, now there is another way to do this, and I said you could use the product rule, but you're actually going to need to use something called the chain rule, and we haven't learned that yet. So I'm going to table that for now. This is perfectly fine to do it this way. It's just that tiny little extra step is you must simplify. You have to multiply by 0 and rewrite it without that. All right, let's look at some more complicated ones like this one. So this one, you've got a product and you have a quotient. So you have to decide what to do first. So you're going to have the product rule in this, and you're going to have the quotient rule in this, but you have to figure out, is this a quotient rule that you start with, or is it a product rule that you start with? Well, the quotient is inside parentheses, and that parentheses is being multiplied. So what you would want to do is you would want to start with the product rule, which is the first times the derivative of the second plus the second times the derivative of the first. Okay, so we'll start. So the derivative is the first, which is this parentheses here, 3x plus 2 over x, times the derivative of the second, which would be negative 5x to the negative 6, plus the second, which is x to the negative 5 plus 1, and then it's time to do the derivative of the first. Okay, well, the derivative of the first is a quotient, so you have to use the quotient rule, which is bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Okay, so first times derivative of the second plus the second times the derivative of the first. So the derivative of the first involves the quotient rule. So that's going to be bottom, which is x, times the derivative of the top, which is 3, minus the top, which is 3x plus 2, times the derivative of the bottom, which is 1, all over the bottom squared. Oops. So when you type that into Excel, well, you've got a lot of things to worry about. So you got this parentheses here, but this horizontal division key is going to need help. So I like to write down my steps underneath, and then just to check my work, this is supposed to be bottom derivative of the top minus top derivative of the bottom over bottom squared, and just recheck it. All right, let's look at another example. So this one, you've got a product right here, but you also have a quotient. And so you have to decide what do you start with. And so this horizontal division is a grouping symbol. So that kind of helps you see that this time you have a product inside a quotient. So you would want to start this one with the quotient rule. And the quotient rule is bottom times the derivative of the top. Now when we get to the derivative of the top, you're going to be needing to use the product rule. So bottom times the derivative of the top minus top derivative of the bottom all over the bottom squared. But when we get to the top, we'll take a derivative. So we'll start here. So start here with the quotient rule. So quotient rule is the bottom, which is x to the 4th plus 3. And then here it is, the derivative of the top, which is a product. So the derivative of the top is going to involve the product rule, which is first times the derivative of the second plus the second times the derivative of the first. Okay. Now I'm going to do this not quite correctly so I can come back and show you why. So don't panic if you already had a game, you know I'm missing something. All right, so here we go. The bottom. All right, here we go. The derivative of the top would be the product rule. So that's first. So that's 2 minus x cubed times the derivative of the second, which is 10x plus 4. So this is first derivative of the second plus the second, which is 5x squared plus 4x minus 6 times the derivative of the first, which is the derivative of 2 is gone. The derivative of negative 1x is negative 1. Derivative of negative 3x cubed is negative 3x squared. All right, so first derivative of the second plus second derivative of the first. Now where were we? That was just the derivative of the top, right? Okay. So that's derivative of the top. I'm going to run out of room, and then I'm going to do minus the top, which is that, 2 minus x cubed times 5x squared plus 4x minus 6. So that's the top. times the derivative of the bottom, run out of room here, 4x cubed. All of that over the bottom squared. Okay. So now I told you I made a mistake. If you type that in the way it is right now, you'll get a wrong answer. And it's because of this addition right here. So this addition, you want to, that is this whole thing in red is the derivative of the top, right? And you want to add these two together to get the derivative of the top. So you have to have an extra set of parentheses here. So right now, without the parentheses, this x to the fourth plus 3 is only going to be multiplied to the first term. But you need to distribute that, or the XL does, or whatever, needs to belong to the whole derivative of the top. And so a lot of people forget to put that extra set of parentheses, and it's because of this addition. So without it, this x to the fourth plus 3 only gets multiplied to the first part of the derivative of the top. But you want the bottom to be multiplied to the whole derivative of the top. Now, as soon as I say that, people then maybe sometimes get confused here, because this was the top times the derivative of the bottom, and you might say, well, I need some parentheses here to group the derivative of the top. Well, you don't, because this is all multiplication. It's kind of hard to see because we got such a long derivative. So you don't need parentheses around, because you don't distribute over over multiplication. So you don't need an extra set of parentheses. So here's what I'm talking about. Let's just break it down. So this means AB plus AC, which is what you want here. Okay, so if you did AB plus C, that would mean a different thing. But let's think about multiplication. A times B times C. If you put parentheses around the product, that you don't distribute that A over the B and the C. That's just A times B times C. So you don't need parentheses when it's all multiplication. You do need parentheses when you're adding in there. So that's why I don't need an extra set of parentheses here, but it's the plus. It's the plus that makes you have to have that set of parentheses. So that's a common error with that. Okay, so that is the end of the product rule. And again, and the quotient rule, what you want to do is practice, practice, practice. So do all the problems in the lab manual and anything extra that I give you to practice.